So good morning all. We're super happy to have you at an 8 a.m. session. So thank you so much for being here. I'm Youssef. I'm a solution architect based in Paris, and I've been working for Databricks for the last couple of years.
Yeah, hi everyone. Thanks for being here, and thanks for coming to this very early session. Super excited to be here to be presenting with Youssef. My name is Yassine, and I'm part of the professional services team at Databricks in Singapore. So I've been with Databricks for 5 years now, and I've been helping customers design and deploy their Lakehouse platform. And this covers topics from governance, security, automation. But across all of these engagements, there was one topic that was often underplanned or overlooked. It's observability. So observability allows you to monitor the behavior of your system and also track all the activities and identify suspicious activities, unauthorized access, monitor the cost spikes that you might have across your workflows, your pipelines, your endpoints, and also make sure the resource utilization efficiency across all of your environments. So that's why today we will be following this agenda where we start by talking about best practices for observability, how to set up, properly define and configure your tags, how to enforce these tags using Databricks policies. We will cover the different types of policies. And next, we will walk you through all the different types of Databricks system tables that provide you all the necessary information to monitor your Databricks platform. And next, we will see a deep dive with using different detailed examples of dashboards to, for example, monitor account usage through our dashboards, monitor Lakeflow usage, and also monitor Databricks SQL usage. And at the end, we will be, as a next step, we will be showing you how you can leverage Databricks demos in order to kickstart your monitoring and your observability journey by using some pre-built dashboards that we have available in the Databricks Demo Center. All right, so before we start, I just want to quickly go through the observability COG, customer user journey, that we can break into 3 different components. So we have FinOps. FinOps allow you to monitor the overall spend, drill down by business unit, by project, forecast the spend for the upcoming quarters, upcoming months, and also define the budgets for different business units, right? Then we have DevOps. So DevOps allows you to monitor the health of your ML models, the health of your data sets, monitor the reliability of your pipelines, your workflows on Databricks. And next we have SecOps. This is where you want to monitor data access, like who's accessing what. If there is, if you can identify any unauthorized access to your data, to your model endpoints, or to your any assets within Unity Catalog. And throughout this whole presentation, we will be following these 3 steps. First, we have setup, how to properly configure tags and policies. Then monitor how to leverage system tables, build your queries and your dashboards for your observability. And the last step is how to manage and leverage these dashboards by setting alerts, sending notification to the right stakeholder in case of a cost spike, in case of an unauthorized access, etc. Okay, so starting with observability best practices, we will be talking mainly about 2 things, tags and policies. So what's a Databricks tag? A Databricks tag is a key value pair that you can set at the level of each Databricks resource. For example, at the workflow level, compute like clusters, endpoints, any type of resource, you can define the tags, but the definition of tags will depend on your organization, like how, what level of granularity you want to have at your organization, right? But we usually see this type of, and recommend this type of tags. So you want to set the generic keys, like the business units, the project, the environment as well. And if you want more granularity, then you can add things like the builder. For example, if it's a specific team that develops some ETL pipelines and using certain compute, if it's a partner, and other tags like the version, the role, the product, etc. Now, once we have the tags defined and created within Databricks, we want to find a way to actually enforce these tags. Make sure that whenever a group of users or a service principal are creating certain resources, they are making sure that they add these tags to these resources. And this is where policies become very handy when you deploy and when you configure your platform. At Databricks policy, we have two types. We can start with cluster policies. So cluster policies allow you to enforce the right configuration in your organization. For example, you want to enforce the version, the runtime version, to always be the latest version when creating a cluster. You want to enforce, for example, the usage of auto-termination. You want to enforce the type of workers or the Spark version that must be used by your team. But in our context, and more importantly, cluster policies can allow you to enforce the usage of tags, right? So whenever a user, a group of users, a service principal, CI/CD pipeline, Terraform try to deploy certain resources, if the tag is not defined, that resource will not be deployed. So if I go through my CI/CD pipeline and try to deploy some resource, it will fail, and I need to first define the tags before deploying these resources. And here you can see an example of where I defined the cluster policy, and in permissions, you will be able to assign this policy to a user or a group of users. So whenever they try to do anything, they need to follow the recommendations that you try to enforce with this policy. And here you can see different examples of the different levels where you can use Databricks policies. So for example, in clusters, in the bottom left, you can see the definition of tags that I'm adding to my cluster when I create the cluster. The one in the middle, you see a Databricks workflow. Again, it defines the tag. For example, the team, it's the engineering team. And the last one is the SQL warehouse or SQL endpoints. Again, we see how the tags are defined when we create the SQL warehouse. Now, once you define the cluster policy, you define what are the tags, and then you grant, as you can see on the bottom right, you grant this policy, not grant, you assign this policy to a certain group of users. And for this one, it's not just the cluster policy, it's more the budget policy, where you can define the budgets and the tags for this budget, and then you assign this budget policy to a user or a group of users. So for this specific one, it's we covered at the beginning cluster policies for classic compute or classic clusters. And this one, it's more for serverless when you start using serverless on Databricks. So when you are using serverless, you're not creating a specific cluster, you're just defining the budget policy for serverless, and you assign it to your different user or different groups of users. So if I go to the next slide, as a user, when I go to my notebook and I try to use serverless, you can see on the right side, I can pick which budget policy I want to use, and it has the tags predefined for that budget policy. And the idea here is that all your users or your teams are leveraging serverless, but they have the tags assigned or attached to these users. So whatever they do, you can use this to track their consumption and their usage by specific teams or by specific business units. And similarly, if you're not using notebooks and using jobs with serverless, you can see that here you define the budget policy, and the budget policy tags is set to engineering. The same logic would apply for serving endpoints. Again, you will define the policy and the tags when you're creating the serving endpoints. So when the user are using this, you can track and drill down the consumption and usage by this specific team. All right, so now that we have defined and configured our tags and also defined the policies, we will see how we can use Databricks system tables in order to build our dashboards and to monitor, start up our observability journey and define the different dashboards that we want. But before starting, what's a Databricks system table? So system table is a list of tables provided automatically by Databricks that contains operational data about your Databricks platform. So whatever is happening in your Databricks account, your Databricks workspaces, it's automatically tracked in system tables that you can find in your platform. And we have different types of system tables that we will go through. And then when we start configuring the dashboards, we will show you how you can leverage these tables to create your dashboards. So first one, we have I will try to break them down by categories. So first category, we have audit, access, and lineage. In this one, you have things like column lineage and table lineage that tracks and gives you a record for each read and write operation on your columns or on your tables. You have things like audits that tracks literally every activity happening within your workspace or within your accounts. For example, if someone tries to create a cluster, any operation happening in your platform will be tracked in the audit table. On the other side, we have billing. So billing allows you to track the consumption of or how much you are using the platform. For example, how much certain workflows or certain clusters are consuming or certain endpoints are consuming. And since we defined our tags, I can use this data and I can filter by the tag, and I have the usage or consumption by business unit or by projects. Next one, we have compute. So in compute, we have all the different computes provided by Databricks, clusters, warehouses. For instance, clusters and warehouses, it's a slowly changing dimension data that keeps track of the different configuration changes within your clusters or endpoints. And this can be really useful to monitor, for example, configuration drifts. If you see that someone changed some certain configuration or you want to roll back to a previous configuration of your clusters. Next one, we have Lakeflow. So Lakeflow, it's the combination of Databricks jobs and DLT or Delta Live tables. And similarly, here we have two things. We have the timeline. The timeline allows you to track the duration of your pipelines. And this is super useful because you can see if there's any spike in the duration or run of your workflows. And then you have jobs, job tasks, and pipelines. Again, it's CDC data that tracks the configuration of your jobs, of your tasks, so that you can keep monitoring if there is any configuration drift. Marketplace, we have two things in Marketplace. The impression, like how people are trying to access or viewing your listings on Marketplace. And the second one is the access events. So any request or approved request will be automatically tracked in this Marketplace system table. Predictive optimization Predictive optimization is done automatically by Databricks, and here you will find a list of operations that Databricks did. For example, vacuum, compaction, clustering, so you can monitor what's happening, what kind of optimization are happening to your tables. And query history, it's straightforward. It's the list of all the queries that that the team or you users executed using SQL endpoints, so you can keep track. And again, you can use them later to see the longest running queries. You can drill down by tags, by business unit, by project, or by user. Next, we have serving. So serving, you have the list of all the endpoints or the models that you are serving and their configuration. And also you can see the usage and the consumption of these endpoints. And similarly, you can break it down by business unit or by user to see how much they are using these endpoints. This one is new. And in short, it's the equivalent of what you see in the UI of MLflow. All the runs, all the experiments that you do on MLflow, you can find them directly in a system table provided by Databricks, and you can use it later in your, for example, in your MLOps pipeline to go through all the different runs and different experiments. All right.
Thank you, Yassine, for all your hard work. As you can see, he did enable system tables. He did the tagging, which is super, super critical for our observability journey. So just to summarize, we have tags that can be applied through cluster policies for classical compute, and we have serverless budget policies for all the serverless compute. Then every single compute or that will be created after those rules will be automatically tagged. So this is very, very important. Then we will leverage system tables to deploy dashboard that will help you track all your costs. And let's start first, before going to the dashboard, we're going to talk about something called budget alerts. This one is very critical. So basically what you can do, you can define the name of the alert. It can be, for example, your I don't know, the business unit, or maybe a specific use case called, for, I don't know, data engineering. You can specify the amount of the budget, maybe $3,000 per month, specify one workspace or multiple workspaces, and then based on the tags that Yassine defined, maybe project equal to data engineering, I will just go like below and define the email that will receive the alert in case we are above the budget. Basically, it can be maybe the finance team or the FinOps team that will automatically receive those emails if you are above the threshold. Then you can also track if you are on track or like below. So this is super, super critical. And this is the example. As you can see, I set up the budget of $35,000, like remaining 20,000. Of course, I spent 14,000. You can see the percentage, and of course, you can also track the current usage. And in case I am above the consumption, Youssef will receive the emails. And the next one is the usage dashboard. This dashboard is very, very important. You can import it if you are like the account, if you have access to the account console, or you can just upload the JSON code that will deploy this dashboard for you. And this one is super critical because you will be able to identify like the costs by SKU, by workspace, the cost by day. So all the things that you should be aware of will be deployed for you automatically. Let me show you how it looks like. But first, you need to go to the account console for those who have access to it. Click on usage, then consumption, and click on set up the dashboard. This will automatically set up the dashboard for you, or you can just deploy it in import this dashboard in your workspace. And once you're done, you're going to have this dashboard. As you can see, I can view the aggregation by week. I can view by billing project, by product, by SKU, by workspace. So I can basically track the daily consumption. For example, I know that in SQL, like from in 1 year, I spent almost 1 million. I can see the variation, whether like I have an increase of consumption or maybe a decrease by SKU. If you have tags set up, you can also filter by tag, by project. And this is brand new, but the version I'm showing you right now, this is the current version. But tomorrow, Greg, the PM of budget, like PM of money team, will announce the V2, which is like a brand new experience with a better UI. As you can see, you will have like the total usage, the aggregation by product, the daily costs, and like the unit, the SKU, the workspace. So we have a lot of things. And of course, this is just an example, but you can go beyond those dashboards just by leveraging system tables, and you can add specific metrics that you want to see on your dashboard and experience. So this is very, very important. We give you the baseline, and then it's up to you to modify, to tailor it to your own experience, which means you don't longer need to reinvent the wheel, just customize it. And for the second dashboard, it's called Lakeflow dashboard, and this one, I find it more critical than the first one. And this one will provide you with a comprehensive monitoring of all your jobs and pipeline experience. And it can really help you optimize your costs, understand the health of your workflows, and who's driving the most usage. Let's go and discover the dashboards. It will be much easier. I need to maybe refresh it quickly. In the meantime, so as I mentioned, this one will help you identify the most frequent job, the most underused resource, which means you can like resize those type of clusters, and also track the most contributors or the jobs that fails the most. Oops. Yeah, here we go. So as you can see, I can track the cost for like the last 13 days. I can see the aggregation of the cost, but let me show you the most important one. So you can see, of course, like the rate of success, failure, skipped, canceled jobs, and then you can see the most important part, which is the most expensive jobs for the last 13 days. So you can see this one costed $3,755 with 4 runs. So basically, you can just aggregate and see the most expensive jobs. Maybe those are the ones that you need to optimize, or maybe switch them to serverless in case you're using classic compute. And that's not everything, because sometimes the job can be very cheap, but a specific run was like super expensive, which means like the basic run like is maybe $5, but one specific run did cost $300. So you can see those runs over here. So I can see that this run ID costs 1,483. So I can, with the run ID, I can open the job UI and understand what went wrong. Maybe I had a spike in the data. Maybe, I don't know, someone pushed the wrong join. So this is really important. And of course, I can also see the variation of the changes. So for example, one job did cost $7 and the next month started costing maybe $400. So it's really easy to go and say, okay, something went wrong here, or then try to understand how you can solve this issue, or maybe you just had more data, and this is good for you, which means you're bringing more ROI to your business. And we have also job cluster analysis, and this is for the optimization. So you can see like the jobs with the most potential savings. So I know that this dashboard, delta to delta, job delta to delta, deserve to have a look at it and maybe go optimize it. And you can also see like the jobs with the lowest CPU usage, which means I can resize this cluster, and the one with the most highest average of memory, which means I need to resize it and increase the size, else I may face the out of memory errors. Of course, keep in mind that some of those metrics won't be available if you're using serverless, because Databricks optimize the workflows on your behalf. So you have a lot of interesting things, and this also very important in case you're using some outdated DBRs. And make sure to always use the latest one, and mainly the LTS. Sometimes it can optimize your jobs, and you can benefit from it. And maybe if Yassine forgot to do his job, you can have a look at the untagged jobs, which can help you like furthermore aggregate the cost. And we have a lot of interesting things like the jobs that are using all-purpose clusters, or what we call the interactive ones. So it is worth like switching to job clusters because they're 30% cheaper. And let's go to the next one. So this one is tailored for data analysts. It's gonna help you track the cost of every single query you're running in your cluster. And you will have, I think there is a talk, a deep dive talk about it. But what you can do, you can either like have a look at the costs for all the types, or you can just say, okay, let me know like the cost, for example, for all the queries that I did run on AI BI dashboards or Genie, or the one I did run on Tableau, Power BI, or any tool using the SQL warehouses. Of course, you will be able to see the number of queries I did run, the user count, and I can also see the aggregations by source type. So as you can see here, like AI BI dashboard cost almost $4,000, SQL queries $800, and you can also see like which one costed the most. Like Ryan here did run a lot of queries. And then you can like either aggregate the cost by day or by week or by month. Of course, it's up to you, but the dashboard is already deployed. And then you have the most important one. You can see like the most expensive queries, like the query, how much it did cost, and you can basically click on the statement ID. It will take you to the query profiler, where we can try to understand how you can improve this query, maybe optimize it furthermore to reduce the cost. So this is a very, very important dashboard that you would need to use. And then we have David demos that will help you kickstart your journey within Databricks.
All right, so hopefully you learned something new. You're excited to start using system tables to kickstart your observability and monitoring in your organization, right? Now you want to go back to your work and you don't want to build all of this from scratch. Maybe if you have something pre-built, something that you can leverage from this session. This is where you can go to Databricks demo center and use the DB demo examples that we have, especially this one. So if you follow this, you install DB demos in your notebook and you select the system tables demo. What it does, it will automatically install all the dashboards that we have pre-built for monitoring. And I will walk you through some very cool examples, some detailed examples that will help you a lot to kickstart your observability journey. So first one, in this one, we can see the list of workspaces, and we can track the consumption by each workspace per day, right? So you can see for each day what are the top consuming workspaces. So if in your design you are building one workspace per business units or one workspace per business domain, here you can see which business unit or which business domain is consuming the most. And the next one, what we can see is for a specific workspace. Now you had an overview of the consumption through workspaces. If you focus on one specific workspace, now you can see the consumption of warehouses, the top warehouses within that workspace. So in this one, we have the list of warehouses. For each day, we have the distribution of how much each of these warehouses is consuming. So we started by workspace, and then we started by monitoring all the workspaces. Then we focused on a specific workspace to see all the different warehouses. Now we can do the same thing for users to have the top consuming users using Databricks warehouses, right? And here I can even filter it by the query source. So for instance, it's ad hoc queries, AI, BI dashboards, alerts, Genie space, workflow, and then you can further drill down to focus on a specific type of query and see the consumption and usage for that type of query. Next one will allow you to monitor the costs per endpoint or per model serving. And here we can see the different types of model serving, like foundation models, CPU models, GPU models. And again, the next step can be to filter by the tag that we created earlier. So you can focus on a specific team or a specific use case or business unit. All right, and again, now if we focus on a specific workspace, I can see the daily consumption by model serving endpoints. And on the right side, you can see again the different types of model endpoints, CPU model, feature, foundation model, and so on. The next one, we want to track the weekly consumption in your workspaces, and also track the health and reliability of your workflows or jobs, like how much jobs failed, running, succeeded, and use all of this data to monitor the health and performance of your workflows. And of course, this data, you can then probably use all the history of your data to actually forecast the spending for the upcoming months to help you define the budgets for each business unit. All right, so we focus on endpoints at the beginning. We can do the exact same thing by focusing on workflows. So here I have the daily consumption or the daily usage by workflow. We can focus, for instance, on specific business units in the production environment or production workspace, and we can track the job execution and get the dollar DBU or the consumption value for each workflow. And of course, if you see any spikes, you should set up alerts to notify the right stakeholders and go troubleshoot to see if it's a normal behavior, if it's just an unexpected spike, or if you need to change and optimize your workflow. All right.
And that's it.
All right, thanks.